Hi, everyone. So as Amy said, my name's Natalia, and I'm a new PhD student here at the Stroke Research Group. And I just wanted to give a brief introduction to myself and a sort of brief overview of my PhD project. So as you can probably tell, I'm originally from the United States. I was born and raised in Seattle, Washington, so that's just north of Oregon and California on the West Coast. Um, and I went to university in Seattle as well at the University of Washington, and I majored in neuroscience, economics, and I actually minored in Russian literature as well. So I got sort of a nice mix of life sciences, social sciences, and the humanities there. But my primary interest was in neuroscience, specifically clinical neuroscience. And I had the really great opportunity to work as a research assistant for about 3 years there. And the research group I was working for actually focused on studying how the brain interprets visual images. So we looked at a bunch of different aspects of an image like orientation, shape, color, texture, blur, you can kind of see. And we essentially studied how the brain processed that information, how it interpreted that information, whether different regions of the brain were responsible for interpreting different types of visual cues. So that was just my initial research experience, and it sort of reinforced my deep interest in neuroscience research, but I knew that I wanted to pivot slightly into clinical neuroscience research because I really valued the sort of daily patient interactions that clinical neuroscience research typically carries. So I knew I wanted to go into that more. So that led me to apply to a master's program here at Cambridge, which I completed last year. And the group that I did that with, they focused on a rare inherited neurological condition called Huntington's disease. I don't know if you've heard of it, but it's primarily a movement disorder. It also has some cognitive impairment components as well as dementia. But one challenge with Huntington's disease, and it's also a similar challenge in CADASIL, is that it's relatively easy to take a genetic test and identify if you have the specific mutation for that condition. But it becomes quite challenging to predict disease severity and progression. So for an individual patient, it's challenging to know when they can expect symptoms to begin or symptom onset to occur, as well as how severe they can expect those symptoms to be. So that's a challenge that I tried to address in my master's program by looking at markers in the blood. So essentially, I looked at different proteins and molecular markers that might have some sort of utility as a predictive marker. So they might be able to tell us something about disease severity and progression, when we might expect onset to occur, and how the disease will progress on an individual patient basis. And with that, we actually identified one protein called neurofilament light, specifically for Huntington's disease, that seemed to have predictive value, at least within our cohort. So that was quite interesting and really rewarding work because I was able to see patients pretty much day to day, do cognitive assessments with them, and really get to know them. So that was really rewarding and again reinforced my deep interest in neuroscience research and clinical neuroscience research specifically. So I knew I wanted to continue doing research, specifically in inherited neurological conditions, or sort of at the intersection of inherited neurological conditions and these predictive markers. I also had an interest in stroke research as well. So this combination of things led me to Professor Markus's group, where I'm starting the PhD. And so that leads me to giving a quick overview of sort of one of the main objectives of my PhD work. I'll be working on a lot of smaller projects as well, but this is one of the main sort of overarching ideas. So to address this sort of challenge of being able to predict or have some idea of disease severity and progression within CADASIL on an individual patient basis, I'm going to be attempting to sort of construct a predictive model for this. So in doing so, I'll be intaking a bunch of different types of information. So again, looking at proteins and other molecular markers in blood samples, looking at imaging data, so MRI brain scans, as well as genetic data and other clinical information such as cognitive assessments and lifestyle factors like smoking status and alcohol intake, for example. So I'll be looking at all these different types of data to try and build a model that will then output, some sort of score, some sort of metric that will give us some information about disease severity and progression in CADASIL. So that's essentially one of the main ideas of my PhD research. And I think it's really exciting and interesting research because it has real potential for meaningful impact, especially for patients, because it enables clinicians to deliver more personalized treatment plans. It gives patients more relevant information for life and family planning. But it's also really useful in terms of research as well, because just to take a simple example, if you have sort of a predictive marker that you've identified in the blood that's sort of easily, easily identifiable in the blood, in other words, then you can use that to assess the efficacy of certain new treatments, potentially disease-slowing treatments. So, for example, you could take a patient and take a blood sample from them and measure whatever specific protein you're looking at before and after they receive treatment, and sort of see how those levels change. And then that'll give you some information about the effectiveness of that treatment. So it has a lot of potential for meaningful impact, which is why I find it exciting. So yeah, I just wanted to give a brief overview of that, and I'd be happy to talk more about it if anybody had any questions or questions about this specific project or my research in general, or anything really. If you wanted to talk about Russian literature, I'd be happy to do so. But yeah, thank you very much.